Hello, welcome to the TA training series on how to perform the power sander and pedestal grinder equipment training. The sander and grinder are used for fine material removal or material finishing, as well as general part contouring. You might be able to see on this part I'm holding, I've used the sander, for instance, to cut some fillets or grind some fillets around the perimeter of my part, and also to sand some chamfers along the part edges. So fillets and chamfers are good examples of what we use the sanders and grinders to create. Before we move into the operation of the equipment, we need to cover important safety protocols. By now you know in our lab we must always wear adequate eye protection, long pants, and proper footwear that completely enclose our feet. However, because these machines are powered by electric motors, we must never wear gloves when operating them. I'll demonstrate the risk on this sander, which is off. If I bring a workpiece to the sander and I'm wearing a glove, the instant that any part of that glove comes into contact with the abrasive wheel, that glove is going to get pulled between the wheel and the table, and it's going to pull my hand in right after it, causing a severe hand injury. So whenever we're using a sander or grinder, the first rule for personal safety is never wear gloves. That means we need to begin by deburring our workpieces before we bring them over to the sander or grinder station. Next, let's talk about allowable materials for use on a sander and a grinder. We'll start with a sander. When using a sander, any material which does not produce hazardous dust is allowable for use or for sanding on the power sander. This includes woods, plastics, aluminum, steel. Again, as long as we can breathe the dust without hazard to our respiratory system, it is okay to sand on the machine. If you find yourself sanding a lot of material where you can see the airborne particulate, then we encourage you to wear a respirator. However, in our lab, we're usually using the sander for less than 60 seconds at a time, so that's typically not necessary. Moving over to the pedestal grinder, in regards to allowable materials, it's a very simple rule. We can only grind ferrous metals. Ferrous, as you know, means the metal must contain iron. If, for instance, we try and grind on a piece of aluminum, on a piece of non-ferrous material, what will happen is the aluminum will actually become hot enough to melt into the porous holes in the grinding wheel. The aluminum will clog those holes, and that will cause the grinding wheel to overheat, and in an extreme case, that wheel can actually shatter and explode. So that is a severe hazard, obviously, to the operator. So to avoid that, we need to remember the one simple rule about any grinder, and that is that it is only suitable for working with ferrous metals. Now, let's discuss proper operation of the power sander. The power sander has an abrasive disc that rotates and a work table on which you place your workpiece before bringing it into contact with the rotating disc. The controls for the machine are located at the top of it. There are 3 of them. There's a speed control, a directional control, controlling clockwise or counterclockwise rotational direction, and there's an on and off switch. For the demo, or the purposes of the demonstration, we only need to teach the students how to use the on and off switch because we leave the sander set up so that the disc rotates in a counterclockwise direction, matching the majority of power sanders they're likely to encounter in industry. In this case, to turn the machine on, they simply move the power switch, the toggle switch, to the upper position. It's spring-loaded, so they have to push it, and then the disc will begin rotating. Next, they can grab their workpiece, place it on the table, the disc sander's table, and then bring the material gently into contact with the rotating disc. Now this is a very important step, or very important point to make. If the disc is rotating in the counterclockwise direction, we always want to use the portion or the half of the disc that would push the workpiece against the machine's work table. In this case, this means only use the left side of the disc. I gently bring it into contact. And you see I move the part left and right along the left-hand side of the disc. in order to spread out the wear and the heat over the entire disc. Don't just position the part in one location and push it against the disc and do all of your sanding at that spot, because you will sand or abrade a groove in the sanding disc. We never ever want to use the side of the disc that is moving upwards away from the table, because doing so would cause the workpiece to be pushed up against the table, and in an extreme case, it can actually fling it towards the operator with enough force to strike their body or even break a light above the machine. So only use the side of the disc that pulls the work down against the machine table. The most important rule next to not wearing gloves when using a disc sander is to never, ever try to freehand workpieces against the rotating disc. If you watch YouTube videos, you'll see examples of people doing exactly this. However, when doing it, if you do it, I'm going to turn the machine off to demonstrate. That means with the machine running, just bringing the part in at approximately, let's say, 45 degrees. You just want to put a little chamfer on your workpiece. So if you try and bring the part in, when you start using a thin piece of metal like the sheet metal, what can happen is the sheet metal can get caught between the disc and the table, between that small gap, and it will get pulled in very quickly, pinching your fingers between the workpiece, I'm not sure if you can see this, between the workpiece and the material, causing a very severe hand injury, actually on both of your hands or both of your fingers, or both of your thumbs rather. Okay, so the rule is we always keep the workpiece in contact against the work table when using the sander or the grinder. If, however, the students or the TAs desire to make a chamfer, for example, then there's an adjustment knob on the right side of the table. You can loosen it, make the adjustment very quickly to the table. There's even a protractor here for convenience, so you can set whatever angle you want, tighten the knob, and now you're ready to turn the machine back on. Press the work firmly against the table and bring it back into contact, moving around perhaps the perimeter of your part. Resulting in a nice uniform chamfer around the entire surface. Okay? So never freehand, always take the 30 to 60 seconds necessary to loosen the table adjustment knobs, rotate the angle of the table, and resecure the knobs. A final comment about the sander, well, actually two final comments. One is that the sander is not meant for bulk metal removal. What that means is we want to limit it to about 1/16 of an inch or less material removal on our workpiece. If I need to cut more than that off my workpiece, then I need to use a coarser machine, like a bandsaw or a milling machine or a lathe. Okay? But the sander and grinder are meant for fine metal or fine material removal, so less than 1/16 of an inch. Second comment is, as we are sanding on both of these machines, actually, the abrasive process by nature is one that produces a lot of heat. Heat will quickly overheat and damage the abrasive disc. So as we are sanding our parts, as it becomes warm to the touch, or hot to the touch I should say, you want to use the water tank in the base of the grinder to cool the part and then bring it back to the sander to resume your sanding action. Lastly, if sanding or grinding on very small parts, for instance, I have a little nut in these, in this demo, then we want to clamp small parts in a pair of locking pliers. Now that would allow us to safely bring the part into contact with the rotating sanding wheel or the rotating grinding wheel without having to bring our hands precariously close to the dangerous abrasion zone. Okay, so use locking pliers anytime you need to sand or grind small parts. Next, let's talk about proper operation of a pedestal grinder. A pedestal grinder uses a rotating wheel, grinding wheel, to abrade material off our workpieces in a very similar manner to a disc sander. However, as mentioned earlier in the video, a grinding wheel is only compatible with grinding ferrous materials. So never, ever bring aluminum or other non-ferrous materials over to use on the grinder. Some very important rules when using the grinder include our number one rule, which we already discussed about not wearing gloves. but right up there next to that rule is the rule to never ever bring your hands into contact with the rotating wheels on the grinder. Okay? That sounds like it might be classified under the category of common sense. However, there's no such thing. And in the case of a grinder, the machine is so quiet when it is coasting to a stop that you often can't even perceive that it's running in a loud environment like a shop environment. In this case, I'm going to demonstrate the proper way to check if a machine is rotating. For instance, if you need to perform maintenance on it. You always want to bring a workpiece up into gentle contact with the machine. In this case, you can see the whole time I've been talking, the machine has been coasting to a stop. So you'd want to make sure that it comes all the way to a stop before making any adjustments, for example, on the machine. Okay? So the first step, don't bring your hands into contact with the wheel, and use a piece of ferrous metal to gently make sure the wheel is stopped before adjusting the pedestals on the machine. So that's the next important thing we want to talk about. This machine has 2 pedestals, one for each wheel, and the pedestals give us adjustments in order to change the angle of contact between our workpiece and the grinding wheel. Sometimes we want to grind the workpiece flat or normal on the end. Sometimes we might want to grind an angle on the end of our workpiece. So the pedestals are adjustable for those reasons. The second reason they're adjustable is that the grinding wheels actually get abraded themselves. So they wear down over time, and what can happen, again, you saw that the machine is off. What can happen over time, a gap can develop between the wheel and the pedestal, and if you are ever breaking our rule that we demonstrated on the sander and trying to freehand a piece of material, if that material gets pulled between the grinding wheel and the pedestal, your finger or your hand is going to get pulled in after it, causing a very severe hand injury. For that reason, the number 2 rule on when using the pedestal grinder is to make sure that the pedestal is set to within 1/16 of an inch of the grinding wheel. The easy way to do it is just do a visual check. If you need to adjust it, that's why these pedestals have quick handles on them, so you can make an adjustment without needing to use, without having to search for tools. Okay? So a 1/16 of an inch gap between the pedestal on any grinder that you use. Next, when using the grinder, we only grind using the face of the wheel. So bringing the workpiece in, we're going to hold it firmly against the top of the pedestal. Again, we're never going to try and freehand the workpiece. We're going to take the time to adjust the angle of the pedestal if we need to grind an angle. Getting back to this, with the workpiece pressed firmly against the top of the pedestal, we only grind on the front face of the grinding wheel. We never, ever try and grind on the sides or the side faces of the grinding wheel. The reason being, if we are too aggressive and we accidentally bring our part into contact with the side of the rotating wheel too abruptly, we can shatter that wheel, and that is a huge wheel to break, and we're going to have shrapnel flying around, and it's going to cause a very serious injury to the operator. So for that reason, we only grind using the face of the wheel. I'm going to demonstrate now. I'll turn the machine on. I have a ferrous workpiece, and I'm going to grind a radius on the end of this part. I'm not wearing gloves. I've checked the gap on my pedestal. I'll bring my workpiece gently into contact with the pedestal, but firmly into contact, and then slide it up into contact with the front face of the wheel, and I'll commence with the grinding action. If I need to, I'll flip my part 180 degrees, and I'll do the same thing on the other side. Okay. As I'm doing this, the part is starting to get warm. As I continue to grind, I'm going to need to use the dunk tank on the grinder, in the grinder base, to cool my part, and then I'll bring it back to the pedestal and back into contact with the rotating grinding wheel. Okay, I will continue with as much grinding as I need to. Again, if I need to remove more than a 1/16 of an inch or so, I'm going to go find a coarser action that will save me time, and then come back and use the grinder for the finishing action. The last important point about using the grinder is to never put excessive force on the workpiece, because in doing so, just like on any other machine, 1, it's going to cause the part to vibrate and chatter a lot more, but 2, if your hand slips or the part slips, then your hand is going to collide with the dangerously rotating grinding wheel. So Understand that sanding and grinding are finishing processes. They are not quick processes. You need to take your time and grind and sand at the rate that the machines are capable of, and never use excessive force, because doing so is going to result in a very serious injury to your body. When we are finished on either machine, we'll turn them off. Behind the sander is a dustpan and dust broom. We will use these to sweep off the base of the machines or the tables of the machines, our work pieces. Obviously they're going to be put away. I just have them out for the purpose of the demo. So we're going to sweep off the tables, and they're going to sweep up the areas around the machines where all of our grinding and sanding debris has fallen, and we'll toss that in one of the lab trash cans. And again, I already made this point, I believe, in the sander demo, but show the students the use of the vice grip locking pliers to hold on to small pieces. For example, it's common that the students might need to grind a T-nut in order to turn it, in order to provide more clearance, for example, for the linear actuator mount. So to do that, they could clamp the T-nut in a pair of vice grips, and then they could safely bring it into contact with the grinding wheel. And it would probably take about 60 seconds to grind that T-nut to a shorter length.